Hello, everyone. This is Rebecca. We still have a few people popping in. So I am going to wait just another few moments and then we'll go ahead and get started. All right. Well, hello, everyone. This is Rebecca Dallin, Assistant Superintendent for Stormwater Quality here at the City of Oklahoma City. I'd like to officially welcome everyone to today's virtual Lunch and Learn event. I hope everyone has a tasty lunch ready to go and is ready to hear from our guest speaker. I myself have some broccoli cheese soup, so be jealous or not, I don't know, but that's what I brought today. In order to reduce background noise, we ask that everyone keep themselves muted during the presentation. If anyone has any questions during the presentation, feel free to type them into chat. And once the main presentation is over, we'll check with our guest speaker, Bruce, and see if he minds if people unmute if you have some questions at the end of the presentation today. But we will have myself and Brooke monitoring chat for questions. And of course, we'll have our speaker, Bruce, answer as many questions as we have time for today. If anyone would like to receive a certificate of attendance, yeah, that didn't work. Okay. Just one sec. Oh my gosh. I hit the right control button. Maybe I will be able to copy instead of paste. Okay, there we go. If anyone would like to receive a certificate of attendance for today's webinar, please send Brooke an email to request it. And I have put her email address into chat so that way you'll have it handy. Each of our presentations in this virtual Lunch and Learn series will be recorded and available in chat if you pop back into this meeting, probably 30 minutes after the meeting is closed. This meeting will stay on your calendar forever. So, well, as long as your IT system allows. I think ours allows these calendar events to stay on for about a year. But yeah, if you want to pop back into chat, you should be able to see the recording there and be able to download it. If you have any technical difficulties or for some reason it doesn't allow outside folks to do that, I'm not sure. It always works for me. It may not work for you. If you are having any technical difficulties and wanting to view that recording, just let me or Brooke know and we'll be happy to get that information to you. So if anyone has any questions at this time, please feel free to type them into chat. Up next is our main presentation for today's webinar. Today we're going to hear from Bruce Leech from Upstream Technologies. Bruce has over 25 years experience in technical sales and business development. He is also a lifelong outdoorsman and fisherman with a passion for keeping our waterways clean and safe, both now and for generations to come. A graduate of St. Cloud State University, he holds a bachelor's degree in business administration with an emphasis in management. Again, if anyone has any questions during today's presentation, please be sure to type them into chat. And Bruce, if you would go ahead and share your screen, don't forget to toggle that switch on to share your system audio.
All right.
Okay, we can see it.
Can everyone see that okay?
Yeah, looks great. Thanks.
Can you see and hear me okay as well?
So far, so good. Yeah.
Great. Well, thank you, Rebecca. I appreciate it. Thanks for taking time out of your day today to find out a little bit about Upstream Technologies and our solutions. My whole goal today is just to kind of let you know what we're all about, the solutions that we have available, and hopefully be another alternative for you, and kind of give you some background on how these solutions came to be, and give you a point of contact, someone that you have seen and put a face with a name, so to speak. So I'll start out with just telling you a little bit about Upstream Technologies. We're a group out of Minneapolis, Minnesota, just north of Minneapolis. And this is northern Minnesota in the summer. If you haven't been here, I'd recommend coming in the summer. Right now, we're a balmy 30 degrees or so. This weekend, we're going to be below zero, though. So winters get kind of cold, but the summers are beautiful. So recommend coming in the summer, and you can see lots of lakes. We're surrounded by them. So we have over, well, I think it's over 12,000 lakes. And this is in an area called the Boundary Waters, which is northern Minnesota. But our company really does have a passion for cleaner water, not only locally, but worldwide, for now and for the next generation. And we kind of sat together as a group and we said, what do we really want to accomplish? Not only is our passion cleaner water, but what's our goal? So we put together a goal at the beginning of 2020, right before COVID hit. And we said we want to save or prevent 100 million pounds of sediment, plastic, and garbage from going into the rivers, lakes, and oceans by 2025. So we set a pretty big goal. Right now, we're closing in on 20 million pounds. And so we have a ways to go and just 3 years to do it. So we're focused on that. And when we get up in the morning, that's what we're all about. We do that through 3 different products, and I'll talk to you about these today. The one on the left is a little bit unique in that it's not stopping the sediment and the garbage. It's actually measuring infiltration rates for sizing those rain gardens and retention ponds, which will prevent the sediment and the garbage from going downstream. This is a automated replacement of the double ring test. And so want to talk to you about that. We're starting to see it kind of different test points around Oklahoma, but we're new to Oklahoma. And so the other reason I wanted to present to you guys today is just to kind of find out your thoughts and if there's any groups that we should be talking to, any associations or hoops that we need to jump through. I would love to get feedback on that. If there's any BMP lists that we need to be on or anything like that. One of the things that we found, our company started in 2012. We were primarily Minnesota. And as we've expanded out into different states, we noticed that every state is a little bit different and there's different groups and different rules and regulations. And so any help with that would be greatly appreciated. And if there's a specific group that we need to get approval by or anything like that, we'd love that assistance as well. The other 2 products I'm going to talk about is the Saffle Baffle. The Saffle Baffle is our flagship product. It's what our company started with back in 2012, and that stops the sediment from going downstream. The other product in that sump structure is called the Skunk. That goes over the outlet pipe and prevents the garbage and the oil from going downstream. So I'll go through these and I guess we're going to wait till the very end for questions, but please feel free to hold on to those and let me know if there's any questions or thoughts. I'll start out with the Mpd Infiltrometer. If we're looking at infiltrating back into the ground and creating like a rain garden or retention pond, we need to know how to size these appropriately. We need to know how well they infiltrate once their ground is saturated. And really, there's only a few ways that this is tested for. And what we're trying to get to is that red line. We want to get to a fully saturated state. And then what's the infiltration rate at that point? And they call that KSAT, or hydraulic conductivity of soil. And there is products out there that just measure like what's the infiltration rate. There's a product called the Turf Tech. They use this in golf courses a lot. And this is just to find out what is the soil at this point in time? Is it dry? Is it wet? Do we need to irrigate? Do we not? But that's not a fully saturated infiltration rate or KSAT. We need to get, as in the chart, we need to get down to a point where it's fully saturated. Really, the ways that this has been done is like a perk test, where you drill a hole and you keep filling it with water until it's fully saturated, and then measure the drop of that infiltration. Probably the most common that we see is the double ring infiltrometer test. And normally I would just ask, is this something that you guys utilize? Do you guys hire these out? Is there geotech companies that do this? But this is the one that we're seeing the most. And the way that it works is it infiltrates the soil on the outer ring and saturates it. And it usually takes a lot of water. These usually take hundreds of gallons of water. They saturate the outside ring, and then they keep that center ring at a constant head. And they keep pumping water into that. This is a very time-consuming test. Usually takes 4 to 8 hours to do these tests, and it's only giving you 1 point in that whole site. So it's very time-consuming, very costly, and very cumbersome. What the Mpd is it's a smaller portable kit that only takes 3 liters of water per test, so less than a gallon per test. And you can go out with a 5-gallon jug and perform these tests throughout the site. It started back in 1993 with 2 guys named Philip and Dunn, and they developed a method to calculate KSAT, or hydraulic conductivity of soil, whether the ground was fully saturated or not. So they created a way to predict what the KSAT would be, whether the ground was dry or wet. And they did it with a falling head test. That went all the way back to 1911 using the green amp theory, and it was updated in 2007 right here in Minnesota. The University of Minnesota modified that method to bring it up to the ground surface. And so in 2007, they created the modified Philip Dunn method, and it went through a series of testing and committees and subcommittees. And in 2018, this was established as an ASTM standard of calculating KSAT. We automated that system that same year. And so now we have the Mpd Infiltrometer, which again, you can go out with just a 5-gallon jug and perform 5 tests on that site. Each test is, rather than 4 to 8 hours, is usually 30 to 60 minutes. So you can get a much better view of the site, a lot easier, and a lot less water. And so that's the Mpd. I'm going to show a short video here, and let's see if we can get this going. This is on our website. So if you go to Upstream Technologies.us and go to the Mpd section, this is a video that's on there, and I'm going to play this. Let me know right away if you can hear the sound.
Upstream Technologies' automated Mpd Infiltrometer follows ASTM standard D8152 and will calculate saturated hydraulic conductivity of soil, or KSAT. It is used to design, build, and test rain gardens, infiltration ponds, bioswales, septic systems, and any location where steady-state infiltration testing is required. Lightweight and compact, the Mpd can go anywhere and uses less than 1 gallon of water per test. This kit utilizes a graduated cylinder and an automated test head to collect the data. The anti-scour baffle and seal prevents the soil surface from being disrupted when filling the cylinder with water. This automated, tablet-controlled system removes any chance for human error. Anyone can operate this instrument with little to no training. Simply consult the in-app guide for step-by-step instructions. This system incorporates a Garmin GPS system to automatically report the exact location the test was conducted. When performing a test, the first step is to take an initial moisture reading using the supplied meter. Slowly press the probe into the ground 5 centimeters and wait 15 to 20 seconds for the gauge to settle. This gauge is in 10% increments. The result today is 30% moisture. Using the wooden set and mallet, tap the cylinder into the ground 5 centimeters. Make sure it is not loose and creates a tight seal with the soil. The anti-scour rubber seal may move during this process. Reach down and reset this seal. Press and hold the button on the top of the Mpd head to turn it on, and a green bar will appear in the app. Tap this green bar, and a dialog box will appear. Enter the initial moisture reading, in this case, 30%, and enter a name to identify this test. Set the tablet down and fill the cylinder with water. Place the Mpd head and hose in and on the cylinder. Pick up the tablet and tap the Submit and Begin Test button. The Mpd app will now turn the green bar to orange to indicate the test is running. The Mpd head will measure the water head drop over time and automatically record the data required to calculate hydraulic conductivity. It is best to let the cylinder drain completely before finalizing a test. This will usually take about 45 minutes to an hour, depending on soil conditions. When the cylinder has drained, remove the Mpd head and cylinder and set them aside. Then take a final moisture reading in the same location as before. In this case, the moisture reading is 80%. To complete the test, tap the orange bar in the app and enter the final moisture value. Then tap the button Finalize Test. All data will then transfer from the Mpd head and will be stored on the tablet. We are now ready to begin another test. Ground variations change and infiltration will vary around the site. Best practice is performing multiple tests and create a site average. Ground variations include soil composition and compaction, boulders under the test, tree roots, and even mole and ant tunnels will have an effect. When testing is completed, the tests are uploaded to Upstream's cloud server, where the calculations take place. A site report may then be instantly downloaded. This report contains a description of the site, a best fit site average, a satellite photo of the site with a GPS map pin for each test performed, and the hydraulic conductivity for each individual test. To maximize time in the field, Upstream Technologies offers a triple Mpd kit, so 3 tests may be run simultaneously by one person.
All right. So that is the Mpd Infiltrometer and the video that's available on our website. I'll get back to the presentation here. As you can see, it's very easy to use, and again, doesn't take a lot of time, doesn't take a lot of training, doesn't take a lot of water. So quite a bit different scenario than the double ring. I talked about the years of testing and committees and subcommittees, some of the testing that was performed. This is a tank that we tested internally to show that it can calculate KSAT whether the soil is wet or dry. We started this out completely dry soil, kept doing the test until there was standing water to show that it calculated KSAT either way. We also tested it in a product called the Thermotron. So it's been tested from 33 degrees to 120 degrees Fahrenheit, and also sea level all the way up to 15,000 feet. So it's good throughout the country. We did a lot of side-by-side testing. This is a local geotech company. We came in and did 4 tests around the double ring. Took us about an hour to do those 4 test points. It took him 6 hours to do that one test. And so we did a lot of that side-by-side testing. And like I mentioned, in 2018, it became an ASTM standard for calculating KSAT. So now it's a lot easier to get this number. What that allows cities to do is be able to manage and maintain these rain gardens much easier. As it said in the video, you can do up to 3 tests at the same time. Actually, possibly more because there's more room. But our biggest kit is the three test kits or 3 tubes. It uploads that information to the tablet. Once that tablet's connected to the internet, it'll upload to our server and do all the calculations, and you can immediately download that report. It'll give you a satellite photo of the site with the GPS pins where you did all the testing, the KSAT for each point, an average for the site, and then all the raw data as well. It's being utilized all over the world. Well, not all over the world, all over the country, into the Scandinavian countries. We actually have some in Norway and Sweden and in Canada. In North America, we're at about 7,000 test points. And when you zoom in, you can see we're surrounding Oklahoma. So part of the reason I wanted to reach out is we're trying to get to states that haven't utilized the technology yet, because I think you'll see it fairly soon. We're starting to get utilized quite a bit in the South. The kits come in 2 sizes. A single kit is $49.50, and that comes with 50 uploads. A triple kit is $99.50, and that comes with 100 uploads. All the components and pieces are under full warranty, so if anything happens, we'll fix it or replace it at no charge. And then if you run out of test uploads, you can purchase additional uploads as low as $15 a piece. So very inexpensive. If you look at even the top number 50, if you did $50 and you did 5 test points on a site, you know, that's $250. One of those double rings is about $800 to $1,000 for just that one test point. So quite a bit less expensive. The other thing that we're starting to see is cities are really using this because now you can do these tests very simply and easily. So they're able to really work on their capital improvement plan of these rain gardens and retention ponds, figure out what the maintenance triggers are, tie it into their GIS software or their asset management software, because it's all digital now. So that is the Mpd Infiltrometer. Wanted you guys to be aware of it. I don't know if anyone has any initial questions or thoughts. Is this anything that you guys use or do double rings at all, anything like that?
This is Rebecca. I haven't personally been involved in any infiltration testing, but that certainly sounds like your system is a lot easier. Has anyone else had any opportunity to do any of those types of tests? You can either unmute yourself or pop into chat.
And if any questions do come up, Rebecca, I think you and Brooke have all my contact information. So if anyone wants to contact me or reach out, please feel free to do so. We really would like to start working with you guys. So I'll get into. Oh, is there a question?
Well, we just had somebody respond. Riza says we've had geotech companies do the test for them, so they've hired other people to do that for them. So
okay, yeah, and that's pretty common. Just because it is so cumbersome and so time consuming that this is something that's traditionally been hired out, but now we're starting to see a lot of engineering firms do it instead of hiring out geotechs. A lot of cities and municipalities, even our DOT is utilizing this technology themselves. So they have a unit that they're using as well. So it just gives you the opportunity to do this testing quickly and easily without having to pay $800 to $1,000 every time. So I will get into cleaning the water and our flagship product called the Saffle Baffle. Again, usually I ask if anyone's heard of that, and first of all, I want to let you know that Saffle does stand for something. That doesn't just rhyme with Baffle, but it stands for St. Anthony Falls Laboratory. This is where our whole company basically started. It's the hydraulics lab on the University of Minnesota campus, and it sits on an island or a peninsula on the Mississippi River. This is a hydraulics lab that was developed back in the 1930s. So it's been around for a long time. As you can see, the river, Mississippi River, runs down below, but what you can't see is it also runs up on top. So there's a 50-foot drop from the top to the bottom, and they use that drop for testing water flow. They have a river that runs through the lab, and then on the outside you can see they test all sorts of ground cover, water flow, different erosion methods, and all sorts of stuff. But inside the lab, they run this river from the top to the bottom through all 3 or 4 levels, and they can do all sorts of testing in there. So it's set up for hydraulics and water flow. People come from all over the country actually to do testing here because it's such a unique situation, and it really gives them the ability to test how that water is going to work, how it's going to flow through the river. So pretty neat situation. And again, that's been at the university since 1930s. So where did the Saffle Baffle come from? Back in 2007, our Department of Transportation was having a big issue. They had installed all these standard sump structures throughout the state. And what was happening is they were capturing the sediment, but if a big storm came through, it would resuspend all that sediment and send a lot of it downstream. So these sump structures were getting washed out, and so they came to the University of Minnesota, St. Anthony Falls Laboratory. They said, "Can you come up with a solution for this?" And so it's really kind of a unique product because the DOT had a problem, and this product was created to solve that problem. It took them 4 years, and after 4 years, they figured out by putting this baffle with a certain percentage of open space, it created this flow through the standard sump structure. And now you could take a standard sump structure, and rather than a 30 to 35% capture rate, they were able to achieve like 80+% TSS removal. I'll show you a video here. This is showing on the left without the Saffle baffle, and then the same amount of sediment on the right with actually a little bit faster flow even. You can see that it, rather than churning that sediment and washing it downstream, it creates a flow and stops that from happening. So now you can take a standard sump, achieve very high levels of sediment capture. All right. As you can see, we're very heavily utilized in Minnesota because the DOT started putting these all over these sump structures, and it's developed and made to be retrofittable. So they were able to put all these Saffle baffles in these structures without having to tear up the streets or anything like that. So it's a product that's created for new construction, but can also be retrofit into existing structures without having to tear up the streets at all. Again, we're starting to surround Oklahoma, so want to talk to you guys, kind of find out what we need to do to have this be another alternative for you, because it fits a certain niche, certainly for retrofit options, but also if there's money constraints, this is a very much less expensive option. So that's where we're at. We're focused on the sediment side, not so much the turbidity. And so we fall right into place with the hydrodynamic separators. I saw that you guys are having, the next meeting is talking about hydrodynamic separators. These are great products. They've been around for a long time, and they do a great job. It's a little bit different because they come complete and it's a full unit. So they need to be primarily new construction or the streets would need to be tore up. So we could just be another alternative depending on what your situation is. Also price wise, most hydrodynamic separators are 20, 30, $40,000. Our average Saffle baffle is about 4,500, so quite a bit less expensive. We also have the advantage because of the way the Saffle baffle is created. It handles real high flow rates, so there's not a need for a bypass system, and that saves on some money as well. When you look at both of these products, they kind of handle the 70 microns and above. Anything more fine than that is more on the right hand side, the turbidity, the real fine. That usually requires like a media filter membrane system, something like that. Those are very expensive, usually like 100,000 or more. One of the things that we've started to see, because they are so expensive, is they'll take a standard sump structure, put a Saffle baffle ahead of that expensive system as a pre-treatment to that. So we've seen that quite a bit, stop the majority of the sediment upstream with the Saffle baffle and be able to vacuum that out and then save the life of that filter system and prevent, extensive maintenance and replacement costs for that as well. About 90 to 95% of the sediment is 70 microns and above, so the Saffle baffle can handle the majority of it. And again, anything smaller than that would be more of a filter type system. We're really trying to help with the sediment issue. The Army Corps of Engineers said they spend about $1 billion a year in dredging, and so lots of money going into dredging costs, because if you're not stopping the sediment, it's ending up in those streams or those lakes, and then that needs to be eventually dredged out, and it's pretty expensive to do that. The other thing that we're seeing, there was a study done in Florida that said about 50% of the phosphorus is in the water, but the other 50% is clinging to the sediment. So if we can get that out of there, we're helping with the phosphorus issues as well. When you're looking at different BMPs, of course, the total suspended solids or TSS is a big thing. A lot of times we see throughout the country, it's like this 80% number is pretty common, but it's not only just capturing it, because those standard sumps were capturing it, but it wasn't retaining it. So now by adding the Saffle baffle to a standard sump structure, we're able to hit those 80+% TSS removal numbers. The Saffle baffle is built on a 100% stainless steel, so built for longevity, and there's no maintenance or moving parts or any issues like that. So once it's installed, it's good to go. The one thing that the DOT was concerned about is they thought, well, now that we figured out how to solve this sediment problem, we're putting something in the middle of this structure. What if it clogs? Are we going to be backing up systems everywhere? So there was lots of testing and stuff performed to make sure that it wasn't clogging or backing up systems. So lots of testing there. If you haven't seen a Saffle baffle, this is what they look like. Again, they come in panels so that all the pieces and parts can fit through a manhole. So it can be new construction or retrofit type situation. So the testing they went through, I mentioned it was about 4 years of testing. They did a lot of empirical testing. They did case studies, real life performance results. But they also worked with Bar Engineering, and they created a third-party software called Shazam. This is not the music software. This is for sizing hydrodynamic separators and manholes. And it's a third-party software that's available through our website. It's available through Bar Engineering. And this gives the ability to test different BMPs head-to-head. So when you guys have a project, one of the things that we're offering because we are new to Oklahoma, is if you have a project that it requires sediment capture, we have an engineer here on staff. They'll take your project, perform the Shazam software analysis, put a full report together and let you know what the removal efficiencies would be, the sizing, the costs, all that kind of stuff. So you can compare it to the other options out there. So the testing, when the university back in 2007, really the only test method out there was the New Jersey test method. And they would take a cup of the sediment before the BMP and then take a cup of the sediment after. And the university, because they were working with bioengineering, needed something way more specific than that. And so they created a new test method called the mass balance method. And this has actually become an ASTM standard for testing as well. And what they did is they took 100 pounds of sediment and they knew the exact particle size breakdown, and they would run that 100 pounds through each of the different BMPs. And they tested like 9 different BMPs. They tested a standard sump structure. They tested the standard sump structure with a Saffle baffle in it, and then a bunch of hydrodynamic separators like the downstream defender, storm scepter, CDS unit. So lots of testing was done. And what they did is they would run it through all the different BMPs, then drain the water, and then they would take the sediment that was captured and put it through a sieve or a sifting system. They'd figure out exactly the percentages of each of the particle sizes that was captured by each of the different BMPs. So now you can compare these different BMPs head to head specific to your project. The testing that they did with the Saffle baffle, they tested for capture and washout, clogging. They looked at low flow rates, high flow rates, different sump sizes, from half foot all the way up to 6 foot sumps. And then they also tested different angles because, as you guys know, they're not all 180 degrees apart when they're coming into the sump structures. So they tested how to place that Saffle baffle, which is another thing that we can help with. We have a guy that does CAD drawings. So if you do put a Saffle baffle on your project, we can help with the placement of that as well. When they looked at the depth of the sump, one of the things that they found was anything under 3 feet, even with a Saffle baffle, they would get washout. So we have a minimum of 3 foot sumps for the Saffle baffle, and that same minimum applies to the skunk, which I'll talk about in a little bit as well for the garbage. So 3 foot minimum. They also looked at the placement of the Saffle baffle, and they noticed if they got too close to the inlet pipe, not only was there a clogging issue, but they also started to get some washout. So the Saffle baffle is put more towards the middle of the structure, not only for the optimal flow, but also for clogging issues as well. It works well with multiple inlet pipes. So when you think about different projects or different ways that the Saffle baffle could be utilized, it can be utilized in multiple inlet pipe situations as well. One of the areas that they found that it didn't work very well is if all the water was coming from the top. So we need that horizontal flow through the sump structure at least 75%. So some of the water can be coming from the top, but we need to have the majority of the flow being horizontal. If it's say a catch basin at the end of a parking lot and it's all coming from the top, we'd want to put this downstream from that so we could have that horizontal flow. Hello? Was there a question?
No, I think someone just accidentally unmuted themselves.
Oh, okay. I'll keep going here. I talked about the garbage. So they did a lot of testing. In fact, they purposely clogged the Saffle baffle to make sure that even if it did clog, which it's designed to not clog, but if something unique happened, it won't back up the systems. And we have over 1,800 of these. I think we're closing in on 1,900 across the country, and we've never had one cause a backup. This particular sump structure is in St. Paul. So we're in Minneapolis, the Twin Cities. The other side is St. Paul. This has a lot of garbage coming through it. And as you can see, the skunk does a good job of stopping all that. And even this one's not backing up. Typically, these are about um, cleaned out about every 6 months. So what we're seeing is kind of a twice a year clean out. This one has so much garbage, they maybe clean it out a little bit more frequently than that, but just kind of typically about every 6 months or so. The Shazam software or the testing, these are the 9 different devices that they tested. Downstream Defender, the Storm Scepter, Bay Saver, um, and then the Saffle, Baffle, and the standard sump. And so now what you can do is you can use this Shazam software, look at the acreage of your specific project, the slopes and pipe diameters, and really compare these BMPs head to head. And this is something that, again, we're offering as a free service. If you guys have any projects with sediment capture needs, let me know, and we can do this analysis for you so you can compare the Saffle Baffle to other options out there. This is an example of one. This was in Madison, Wisconsin, and they had to hit 80% TSS removal to get the permit. And so they tested it, and it was a 2-acre site. And they said, well, if we have a 4-foot sump, we're only at about 32% capture rate. So they added a Saffle Baffle to that, and it jumped all the way up to 71%, but they needed to be at 80% to get the permit. So they said, well, we could add a second sump structure, or what if we just make this one sump structure a little bit bigger? So they changed it to a 6-foot sump, and they were able to hit that 80% for 6,600, which included the sump. The Storm Scepter, the Downstream Defender, the CDS unit, as you can see, they even did a little bit better. They do a great job of capturing, but they were 3, 4, 5 times the cost. So this is the kind of analysis you can look at with that Shazam software. The Saffle Baffle, again, is 100% stainless steel, and it's really built for longevity. This, again, are the pieces and parts. The way that it's installed is the side pieces go into the structure, and those are drilled into the structure. The top piece is put on, and then depending on how wide the structure is, those panels are hung on that top piece, and then the bottom piece locks it all in. Once it's in, you don't need to do anything. There's no maintenance to it at all. It has a 20-year guarantee. So when you guys look at different BMPs, the Saffle Baffle is guaranteed for 20 years. So if anything happens to it, if it bends, it breaks for some reason, we'll replace it and fix it at no cost. Each Saffle Baffle is date stamped, so it's under full warranty from 20 years from that date. So just so you guys are aware of that. Our DOT, I mentioned, they put a lot of these in. They actually called out the Saffle Baffle back in 2017, and they said it's working so well that it's going to save the state about $26 million over the next 10 years. So we were excited to see that they called it out, but it does a good job of stopping that sediment, eliminating the need to dredge as often, and really does a good job of stopping the garbage too. We're also being approved across the country for pre-treatment. I mentioned pre-treatment in front of like a filter system, but we're also being utilized in place of like forebays. A lot of times these developments don't have a lot of room for the forebay, or maybe they don't want a forebay that they're going to have to dredge, or floating garbage or something like that. We're seeing a lot of retention ponds with a sump structure and a Saffle Baffle in front of them as pre-treatment. If they have garbage, they're putting a skunk in there as well. So pre-treatment before retention ponds. We're also seeing a lot of these underground chambers. This is a 3M parking lot here in Minneapolis. They had a big underground chamber, but they put 3 sump structures ahead of it with 3 Saffle baffles, and they were able to create a situation where they could stop the sediment before it goes underground. So we're seeing that, a lot of pre-treatment. Um, I mentioned it being a retrofit option, a couple that we've run into, and these are just situations that if you ever run into a problem or a situation and you're looking for a retrofit situation or a solution. We had one in Utah. It was a downstream defender, which again, these products work great. These were just specific situations where they ran into an issue. Um, that top one, the downstream defender in Utah, there was rocks that were coming through the storm drain. And in about 3 weeks, it chewed up that yellow plastic that's inside there. And they had already put the street in and everything was covered. And so they didn't want to tear up the street. So they said, can we take this out and retrofit a Saffle baffle across that 10-foot structure? And so we put a Saffle baffle in place of that yellow plastic, and we had to double stack it. It was a pretty big one, 10 foot across. And I talked to him about a year and a half after the installation, and it's been working great, not only for the heavy flows, but also handling those rocks coming through. The one on the bottom is the Storm Scepter. This was in Colorado, and this one was installed kind of near a mountain, and the flow was always over that eight cubic feet per second. So everything was going through the bypass all the time. Nothing was going through the system. And so they did a similar thing. They cut the insides out. We retrofit a Saffle baffle across there, and it immediately started taking all the garbage and everything through the system and stopped by the Saffle baffle. So um, this worked out so well for them. They did it to 2 more that summer, and then the following summer they added 3 standard sump structures with Saffle baffles because it was handling the high flows so well. So a couple retrofit things, um, some knockoff things that we've seen. This is a plastic knockoff called the Preserver. Um, they came out here in Minnesota. I don't know if you'll see them in Oklahoma. But because our patent is in the middle of the structure, they had to put it to the inlet side, and it's plastic, so it wraps around the inlet pipe. And because it was so close to the inlet pipe, they were getting the washout. So they had to put another piece over the outlet pipe. And we've had a lot of these clogging up here. So something for you to be aware of. We've had a lot of contractors that worked with cities and said, hey, this is another baffle. Can we put this one in instead? But it's quite a bit different. This one's plastic, the Saffle baffle being stainless steel. And if that inlet pipe sticks out at all, they're getting installed right up against those. And so these are causing major flooding and clogging issues. We've had maintenance crews that have had to go in and cut these out with knives. We had one guy that had to use a ramrod to get it out of there. And again, that's one of the things that was so great about the development of the Saffle baffle. They did it at the university, and they took time to make sure that, hey, we're not going to have clogging or flooding issues with this product. Um, so that's something just to be aware of. Um, Also, they have this piece over the outlet pipe, which is open on top. So it's not a garbage guard. Um, it's to stop the sediment that's being resuspended. But the worst one was a big storm came through and pushed that plastic up against the outlet pipe, and it backed up that system like 2.5 feet of water in the street. So something to be aware of. Um, the other thing that we've seen is contractors that just said, well, I'm just going to cut holes in a piece of metal because that's what the Saffle baffle looks like. The unfortunate thing with this is this was only about 25% open space. And so it was actually creating more of a turbulence than if it wasn't in there. That 4 years of research and creating this product to solve the problem came up to this 48% open space, which is kind of the magic number, I guess. And it creates that flow through there, stops any resuspension from happening. And again, it took 4 years for them to figure that out, but that's kind of the magic number of the Saffle baffle. So now you can take a standard sump structure, put a Saffle baffle in there, and achieve those kind of removal rates that you really want to achieve. 80% TSS removal, handles real high flow rates, and again, guaranteed for 20 years. So that's the Saffle baffle. I just have a couple more slides on the skunk. Should I just keep rolling? And so the skunk is our newest product. This kind of came out of a situation in Maryland that there was another product. As you know, there's lots of products that go like hoods, garbage guards, things that go over the outlet pipe. But we were partnering with another product at the time, and they sealed the structure. And so they were going to be able to retrofit the Saffle baffle in there, but they couldn't fit the hood through the manhole. And so they called us and they said, hey, do you have a retrofit option like the Saffle baffle where we could put that in instead? And at the time we didn't have it, but we thought that was a pretty good idea. So we went into a 2-year research and development and created the product called the Skunk. Very similar, goes over the outlet pipe. It's totally enclosed, so it stops all the garbage and all the oil. As you can see on the left, it sticks a foot below the outlet pipe, so it requires a 3-foot sump as well. And the clean water is able to go underneath and go through, and it stops all the garbage and oil. Comes in panels. This is what it looks like. Has a vent out the top so that it doesn't cause any vacuum or suction issues. And it's very easy to install, and can be new construction or retrofit as well. Made in the USA, and that is the Skunk. I guess I'll open it up. Any hurdles, issues, thoughts on the Saffle baffle, the Skunk, or the Mpd for anyone?
If anyone wants to unmute themselves and visit with Bruce or ask him some questions or respond to his questions, feel free to unmute yourself. I don't see any questions in chat at this time, Bruce. I did put your contact information in there for attendees.
Great. Okay.
I think I've seen some of the alternatives to the Skunk and some of the like the snouts and things that are out there. I'd seen some of those in like the Stormwater magazine that I get. But I don't know if I've seen your products or not in there, but it's really interesting to see some of the research and information behind how those things work. And quite frankly, that Saffle baffle, it's a piece of something with holes in it. How does that stop sediment? I mean, it's just so counterintuitive. I just find that fascinating.
Yeah, well, and again, I think the most interesting piece about it is when the university started, they didn't have anything. It was just, okay, how do we solve this problem? And they started out with just like a solid piece of metal, and they, went from there. And it took them about 4 years, but once they got to that certain point, it just created that flow through there, and it's pretty amazing. Pretty simple product, but it took a while to figure that out. So my only question is, does anybody have any projects we could do that free analysis And if not now, certainly keep us in mind because we'd love to work with you guys.
We might have some projects, and I'll visit with you afterwards. But yeah, we might have some projects that you might be able to help with.
Yeah, it'd be great to do the analysis for you anyway, just so you could see how it would operate and you know how the removal efficiencies would be specific to that project too. You know, so.
Yeah, I know we've got several industries around Oklahoma City that have considered and or installed some of those storm scepter type devices. And then as the city, we've been installing a few of those storm scepters or similar products out and about. So yeah, it's just really interesting, and I hope that people do take you up on your offer for that free analysis, because I think that information is invaluable. So
Great. Well, I really appreciate everyone's time today.
great.
And like Rebecca said, if you have any questions or something pops in your head a week or a month, or just feel free to shoot a question or give me a call.
Cool. Thanks so much, Bruce. What a
Thank
great
you.
presentation and such interesting information. I really appreciate it. I see someone typing in chat. We'll see if we get a question. So if you don't mind hanging out for just a minute, that'd be great.
No
Looks
worries.
like we've got a very informative. Thank you. So good work there.
Oh, great.
As a reminder, if anyone would like to receive a certificate of attendance for today's presentation, please send Brooke an email to request it. Be sure to not request those certificates of attendance in chat, because we may not have your email address associated to your username on Teams. But again, if you'll just email Brooke, and I've posted that again into chat. So if you'd like a certificate of attendance, please shoot her an email. We should be able to get those out hopefully this week. I am recording this presentation, so it should be available by if anyone wants to watch it, you can rejoin this meeting and access it from chat. It should be posted in there. But if there's any technical difficulties or if that doesn't work for people that aren't actual City of Oklahoma City folks, just let me or Brooke know so we can get that information to you. Don't see any questions in chat still, so thank you all for attending today's session. We hope everyone enjoyed the presentation. We hope to see everyone at one of our upcoming webinars. February 16th at 1 p.m. is the next installment in our Stormwater Quality webinar series. The information will be provided by Chris Stewart, covering industrial stormwater pollution prevention plans. Our next virtual lunch and learn is scheduled for April 13th. We'll be hearing from Advanced Drainage Systems. Dirk and Stephen will be presenting their product information. If anyone still needs to register for either the monthly webinar series or the virtual lunch and learns, please be watching your inbox for an email from Brooke. If you don't currently get emails from Brooke, make sure that you email her. Have a great afternoon, and thanks again. Thanks. We'll hang out here for just another minute or two, if you don't mind, Bruce. I've got a question for you myself.
Okay.
But yeah, if you don't have any questions, don't forget to hit that red leave button in the top right-hand corner. And thanks again, everyone.
Thank you.
Thank you, Bruce.